G'day, in this video we'll be talking about the plant health pyramid. This is an idea suggested by Kempf from Advancing Eco Agriculture. So firstly, full reference to them for thinking of this way of thinking about plant health. But effectively today we're going to be going over their concept as a plant health pyramid, the minerals and nutrition you need and what it's all about. Before we get into that, my name is Till Simmons. I run Agresol, which is a regenerative consulting business in Australia. So if you want to practice some of these things that we're going to be talking about today to build up your plants' resistance and immunity to pest and disease, get in contact with us. We can set up a free 30-minute consultation to see how these things can fit into your operation. We can also do differential subtest analysis and soil testing for you. So go check out the website at agresol.com.au. And then finally, we've also written up this whole video on our website. So if you do go to our website, you can see all the supplementary material all written up for you. There's a lot more information in there. So go check it out. It's fantastic. Cool. So before we actually begin on John Kempf's idea of the plant health pyramid, there's a lot of literature out there that already supports the concept that a healthy plant with correct nutrition resists pest and disease. And so we have firstly mineral nutrition of higher plants or plants. Fantastic book. It's definitely worth a copy if that's what you do. It's expensive, but it's worth it. There's also mineral nutrition and plant diseases, also a fantastic book. So this outlines effectively the relationship between so many minerals, almost all of them, and their role in plant immune systems and resistance. There's also a book called Tuning into Nature, which is about the ways that insects and plants communicate, specifically how pests will detect sick plants for them to attack. And then finally, I'm pretty sure this is the earliest bit of literature, or maybe not earliest bit of literature, but definitely the foundation of the whole topic, which is Healthy Crop by Francis Jabusu. I have a video on some of his work here, so you can go check that out. But effectively, Jabusu comes up with the idea or the theory of trophobiosis. And that is simply that pest and disease is nutritional in nature, meaning that whenever you have a pest or disease, it means that your plant is sick, and that pest or disease is coming only to eat on the plant because it's food available for the pest or disease because it's sick. And so he explores in a bit of his literature that a lot of these pests and diseases are after free nitrogen. So this can be nitrate, ammonium, even amino acids in plant sap, as well as reducing sugars. Now, reducing sugars are simple sugars, things like glucose are also in the plant sap. And so I guess the whole idea is that when you have a system or a plant that is not effectively converting nitrogens into proteins, complete proteins, and sugars into complex carbohydrates, then you get a high amount of pest and disease pressure. And from all the literature I read and all those books, this seems to be the case, and it fits perfectly into a integrated pest management system. So John Kempf has kind of taken this understanding and some of the understanding from other people, and they put it all together into a really nice concept called the plant health pyramid. And so we'll start with the very bottom of the pyramid. The bottom of the pyramid is foundational to all things. You can't build on top of the pyramid if you don't have the bottom. And so they highlight that the first step of the plant health pyramid is complete photosynthesis. Now, if you go check out this video, what is photosynthesis, and the second video, how to increase photosynthesis, you'll understand that photosynthesis is really the generator of the plant. Photosynthesis produces all the energy that a plant can really use. And it's the powerhouse to drive all the activities, the growth and development of the plant, the reproductive ability of the plant. This maximizing photosynthesis is so important to the plant because really that's where it's getting all of its food from. And so the very first component of the plant health pyramid is ensuring that you're getting complete photosynthesis. Now we can achieve that with correct plant nutrition. Now John Kempf estimates that you can increase the photosynthetic ability of most of the plants that they work with by 150 to 600%, which is a 1.5 to 6 times the increase in photosynthetic ability. Now, if you increase your photosynthetic ability by 6 times, you effectively have 6 times the amount of sugars that can be used for growth and development, increasing effectively yields as those sugars go into filling out your grain or fruit, and more excitingly, gets pumped into your soil as root extracts to build soil organic carbon. So increasing your photosynthetic ability of your plants is fundamental to ensuring a healthy plant. And on top of that, it allows you to build these other things. And so ensuring you have a high amount of photosynthesis will ensure that you can increase the carbohydrate profile or improve the carbohydrate profile in your plants to start resisting some pest and disease. And so the minerals required for that is firstly nitrogen. Nitrogen is required. It's in the center of the chlorophyll molecule. I'll have a photo coming up there. This is required for chlorophyll. Chlorophyll is required for photosynthesis. So it's the structure that actually captures the light. So we need to make sure we have heaps of those in order to capture light. Next is magnesium. Magnesium, as you'll see, is the center of the ring. So we have magnesium and then surrounded by nitrogen molecules. Likewise, if we don't have magnesium, we can't have the chlorophyll molecule, which is needed to capture the light. Next is iron. Iron is used in 2 ways. My understanding is that the first way is that the enzyme that attaches the magnesium to the chlorophyll molecule requires iron to do that. And then next, it's used in carotenoids, which extend the range of light that the plant can capture. So if you think of plants only being able to capture that much light, it extends the window to that much light. So you can take in more blue and red wavelengths of light. So next we have manganese. Manganese is used in hydrolysis, which is a step in photosynthesis. What happens is your water molecule comes along and gets split by an enzyme which uses manganese as a cofactor. And then finally, phosphorus. Now, phosphorus isn't actually used in photosynthesis itself, but it's used in the production of what's called ATP, or adenosine triphosphate. This is almost like a battery, and it gets charged up and allows the transfer of energy away. So it's really important that we have phosphorus because this whole system is generating energy. It's kind of recharging these batteries called ATP. And ATP can then be used throughout the cell or the plant as energy. So when we work with growers, we use differential subtest analysis, and this is the first thing we look at when looking at a subtest. We make sure that the plant has sufficient levels of all of these so that the plant will be photosynthesizing to its maximum ability. So once that happens, the plant becomes resistant to a lot of soil-borne fungal pathogens. So once we have complete photosynthesis, we can then start building the rest of the pyramid, and the next step is complete protein synthesis. Now this involves the rapid conversion of nitrogen or free nitrogen, such as up here. So that's nitrate and ammonium, as well as amino acids, into complete proteins. Now it's very important that we get them rapidly moving into complete proteins because then it ceases to be food for pest and disease. And so plants need to be able to convert all of that nitrogen into complete proteins in a 24-hour period. And once that can be achieved, it starts to develop resistance to our next level of things. So the minerals needed for that are magnesium. So this magnesium is also used in the ribosomes, which piece together all of our amino acids into a polypeptide chain. Then that gets twisted up into a protein. Next is we're going to make sure we have enough sulfur. Sulfur is used in 2 amino acids, methionine and cysteine. These are very important, especially methionine, which is used in all proteins. So methionine starts the polypeptide chain. And so you can't have any protein, like no protein can start without methionine at the start of the polypeptide chain. Which means if you're deficient in sulfur, you can't start these polypeptide chains, which means you can't be building proteins. So very important that we have sulfur so that we can build complete proteins. Because otherwise our nitrogen is going to start being backlogged and won't be able to get converted into proteins, which is where we need them. Next is molybdenum. We're going to make sure we have enough molybdenum for the nitrate reductase enzyme. This enzyme converts nitrate to nitrite before it then can be converted to other things. And so if you don't have molybdenum and you're applying a bunch of nitrate, to your plants, or you're supplying a bunch of nitrates to your plants, it means that you're going to be building up nitrates and you can't convert it regardless of the amount of all these other things. So it's very important we have molybdenum, and a lot of farms are deficient in it, and all you got to do is apply a foliar application of it, and that's effectively it, and you can start moving along a lot of those nitrates and reduce your pest and disease pressure. In a similar way, nickel's also very important, and not many people test for it. It not often deficient, but it can be. That's used in a similar way to molybdenum, and it's used to convert urea to ammonium, which means if you're applying a bunch of urea fertilizer and you don't have nickel and your plants are deficient in nickel, then you're building up a backlog of urea either in your plants or in your soil, and you're not actually supplying a plant nitrogen. You're getting a backlog. Next is boron. Boron is not used in protein synthesis itself. It's similar to phosphorus in that sense. It's used in the translocation of sugars or minerals and nitrogen throughout the plant. And so it's very important that we have boron, because otherwise you're going to be building up our nitrogen and sugar levels in particular points around the plant, making it an ideal source of food for pest and disease. So we've got to make sure we have good boron, so it's moving everything around the plant. So a good way to test this, if you use a Brix reader. So a Brix reader looks at dissolved minerals in the plant sap. And so what you can do, you can take the sap reading, say the night before, and then in the morning, you want to see a high level of Brix in the afternoon, and then a very low level in the morning. That would suggest that the plant is translocating those the photosynthesis at the end of the day throughout the plant. If you have a high level in the afternoon and a high level in the morning, it means that they're not moving around the minerals, meaning that you have a boron deficiency. Now, I'll have a whole video about using refractometers and super fancy garlic press to predict some plant health aspects. But anyways, there'll be another video. Now, once we achieve our complete protein synthesis and we're converting all of our nitrogens in our plants to complete proteins every 24 hours, we will start to protect our plants from larval and sucking insects. So things like thrips, aphids, a lot of grubs, as well as corn earworm. Our plants can start to resist against those when we have complete protein synthesis. Now, there's a few things that we need to talk about in this level that is, I guess, addition in what John Kempf usually talks about. Well, what I've found in reading some of the literature is that there's a few things that prevent this system from occurring and can drive it backwards. So the first one is the application of pesticides and herbicides. They prevent protein synthesis. And this is really well outlined in a healthy crop. Now, with the application of herbicides and pesticides, it's what's called photosynthesis. Now, this is when proteins start to basically denature back into amino acids, which means if we have free amino acids in our plant sap, it's making it perfect for pest and disease to consume our plants. Which means when we apply herbicides and pesticides, we're actually creating plants that are more favorable for our pest and disease. And I know it's hard when you have pest and disease, and it's above the economic threshold, you really do need to apply pesticides. But if we can try and manage our crops using this framework before that happens, then that's even better. So it's an important thing to keep in mind. It can actually take up to a week for our plants to fully recover, meaning our plants are going to be susceptible to pest and disease, during that time. One way we can kind of overcome a bit of that is applying fulvic and humic acid in our pesticide and herbicide applications. That gives the plant a bit more energy to overcome and bounce back after herbicide and pesticide applications. So it's a really good idea if you're going to apply a pesticide to add a fulvic or humic acid. Your plant's going to bounce back a lot faster and you're going to have less pest and disease. Now the second one is photorespiration. So photorespiration is when the plant gets too hot and the Robisco enzyme, which is in charge of taking the carbon dioxide and then fixing it to a carbon component, which then produces our glucose. That thing gets mixed up and starts to grab oxygen, and effectively what happens is the whole system breaks. So what happens during photorespiration that makes it so bad is that an amino acid that's used in the process is broken up into carbon dioxide and ammonium. Now this needs to then get detoxed by the plant, wasting a whole bunch of resources and energy of the plant. It also builds up nitrogen, which we don't want. We don't want to build up nitrogen. As I said, this happens when plants get too hot. Typically it's about 25 degrees for C3 plants and 30 degrees for C4 plants. But what happens is that the stomata close and oxygen starts to build up inside the plant, meaning that the rubisco enzyme then starts to grab oxygen. Another way to really overcome that nutritionally is with our next step, and we'll get into that in a moment. But we can also do cultural practices like keeping our ground covered and making sure we have a thick canopy to reduce the canopy temperature. So before we continue up our plant health pyramid, I want to talk about passive immune systems and active plant immune systems. So the first two parts of the plant health pyramid are all built off, I guess what we can refer to as passive immunity. This is where plants are no longer food, like food as itself, for the pest and disease, meaning that a lot of pest and disease won't simply attack our plants because they're just not food. Now, once we start getting into the next two parts of our plant health pyramid, we get into an active plant immune system. This includes systemic acquired resistance as well as induced systemic resistance. And both of these have a big role in our plant's immune system. So the first one, SAR, is a type of pathogen-induced resistance. It tends to be broad spectrum, and during a pathogen attack, the plant will start to generate these signaling compounds to prepare the plant for infection. Next is ISR, which is a resistance mechanism triggered by the infection itself, and doesn't actually depend on killing the pathogen itself, but simply increases the physical and chemical barriers to prevent the pathogen from spreading. So I'll talk about those because it's these two levels that actually induce those active plant immunities. So once we have achieved our complete protein synthesis, we can then move on to increased lipid production. Now lipids are fats, or fat is a lipid, I guess. But when you think of lipids, think of fats and oils and some other things. Now, in order for a plant to produce lipids, it needs an abundance of energy. But once it achieves a higher amount of energy, it can then start to increase its lipid production, which means we can start to build a lot more flavor in our produce, but as well as increase the thickness of the waxy cuticle, which is a waxy layer or coating on the leaf, which means we get a number of different benefits. The first one is when we come back to photorespiration, it cools the surface of the leaf. It acts as a buffering surface to reflect light when temperatures get extreme, which means we're going to reduce the temperature of our canopy as well as reduce evaporation. So we increase our water use efficiency, which is fantastic. But then we also increase the resistance to airborne pathogens, as it takes a lot more effort for these pathogens to actually break through that waxy cuticle, and it prevents them from making entry into the plant. So things like rust, powdery mildew, a lot of those funguses, airborne funguses are included. So our plants can become resistant to them. Now this level is it is nutritional in nature. However, we can't simply just apply nutrition like our other two layers in order to achieve that. What we need is really, really strong biology in our soil and in the rhizosphere of our plants. And the aim of this level to ensure that we increase lipid production is that we want all of our nitrogen sources to be supplied to our plants as microbial metabolites. The reason for that is that when we have nitrate and ammonium, the plant actually needs to convert both of these into many other forms before it can actually become, say, an amino acid and then a protein. What if we just supplied our plants amino acids or amino sugars, which is the AS and AA's amino acid, so that the plant can take that up and then it skips out on that whole conversion process. Now, that's super important because the energy required to convert, and also the water required to convert, say, nitrate, is about 23% of the root energy, which is massive. So think if we could increase our overall plant energy by 20%, it provide the plant with so much more energy that it can put that into lipid production. Likewise with water, I think there's a 1-to-3 ratio with nitrate to water requirements for that conversion. So increase our water use efficiency as well as increase the amount of energy available for the plant to do its thing. And so how do we ensure that we can provide a microbial source of nitrogen? There's a few ways of doing this. We can firstly tap into the rhizophagy cycle, which is where our plants actually eat microbes. We have a video slightly touching on that. We'll do a whole video specifically on rhizophagy cycle in the future. But effectively, the plant eats the microbe, rips off its skin, consumes that as a source of nutrition, and then spits the microbe out sometimes. For then that microbe to then recycle through, collect nutrients, and then supply it back to the plant. Super cool. Now the other way is that microbes release amino acids, specifically if we have predator microbes, so say a nematode or a protozoa. They consume on fungal or bacterial prey and then release microbial metabolites into the soil environment for our plants to then consume. Now we can really boost the amount of microbial activity in our soil cover crops as well as inoculants. Two fantastic ways to increase microbes in our soil, which then build this store of organic nitrogen. However, if we're a bit low on that, supplying nitrogen as amino acids as a foliar spray is a really effective way of supplying amino acids to our plants. We can also supply urea, which is slightly better than nitrate and ammonium. But really the key to this is building up the microbes and the biology in our soil to then supply our plants with all of its nitrogen requirements. There's also a whole range of other soil health practices like good rotation, using multiple species, no-till, ground cover, all those things improves basically our soil health in our microbes. We have another video on that, you can go check it out here, on the 7 principles of soil health. Now, finally, the last part of our pyramid, the capstone, the most important, and we're going to get the most benefit out of it, is that increase of plant secondary metabolites. Now, it's these things that provide the plant with flavor as well as its medicinal properties. So if you think of like curcumin and turmeric, this ensuring that we have a high amount of secondary plant metabolite production increases that medicinal effect of the plant. But other things like vitamins, flavonoids, all those things, very important. This increases quality and our plant's ability to induce some of that acquired or activated resistance. And this is triggered by the plant's microbiome. And it's super important that we have a really strong and robust microbiome of the plant, because simply that's the only way that we can induce an increase in plant secondary metabolites. Once we achieve that and we can increase the plant's immune system, the plant becomes resistant to a lot of beetles as well as nematodes and viruses. And so really that's it of the plant health pyramid. It's a really fantastic way of understanding plant health and a really good way to kind of prioritize different aspects of nutritional requirements. Starting off with increasing photosynthesis, then moving to increase or complete protein synthesis and increase lipid production, and then increase plant secondary metabolites. And thinking about how we're applying some of those minerals and the forms of minerals that we're giving. And there's a few things that John Kempf's plant health pyramid doesn't quite consider, even though it's fantastic. There's a few other things we need to consider. That is, there's a lot of other minerals that contribute to plant resistance to disease. A lot of them are outlined in our fantastic book by Don Huber, the Mineral Nutrition and Plant Disease book. Things like a lot of our trace minerals. So iron, even though we have it over there. Copper, quite important. Zinc, very important. Manganese, very important, more so than just its role in hydrolysis. I didn't add it here, but there's also selenium, which is also super important for plant health too. Now, in addition to that, calcium, silicon, and boron are very important for increasing the strength of cell walls, making it more difficult for say fungal pathogens to break through that cell wall or other pathogens. Having really high levels of that in our plant can really increase its resistance, its physical resistance to pest and disease. Now this whole thing is very good, and we consult on this, but we also consult on other integrated pest management strategies. This is simply just one component of your integrated pest management. You still need good crop rotation. If you're just going week to week to week or cotton to cotton to cotton, regardless of how well all of this is your pest and disease, there's a good chance that it's going to be higher than the economic threshold. And so this should all be considered within an integrated pest management. Now, making sure you have good farm hygiene. Applying microbes like predatory microbes like trichoderma, which is a predator fungi to hunt down other fungi pathogens, as well as good crop genetics too. All of these things need to be considered with, in addition to our good plant nutrition and microbiology. So if you're a farmer in Australia, you can come work with me. We can do some differential sap test analysis to know exactly what your plant needs in terms of all our minerals. We can also do Aubric soil tests. We can calculate your organic nitrogen components, so effectively this component of your soil. We also do total tests. We can also give recommendations on the microbial inoculants and inputs you need to achieve high levels of plant health to resist pest and disease. Awesome. So if that sounds like you and you're a farmer really wanting to regenerate your system, you can actually sign up for a free 30-minute consultation on our website. I'll put the link there. Otherwise, if you're everyone else, make sure to subscribe, because it's this YouTube channel that we can get a lot of this information out to people for free. Awesome. Again, there's a post outlining all of this on our website. Thank you very much for watching. My name's Teal Simmons from Agresol. Cheers.